Alright everybody, we're going to actually come through and we are going to work on a little more difficult problem with number 6. But before we do that, I forgot to check on the last one. If you were a little curious to see if your math was correct, I do have 4 over 3, and that's equal to 8 over 6. And I know if I go through and either turn these both into decimals, or in this case, we could just go through and reduce our fraction over here by 2. This will give me 4 over 3 equaled to 4 over 3. Ooh, that is ugly. 4 over 3. So that works right there. Okay. Now let's take a look at a little more complicated one. Now in this case here, we still have a fraction equal to another fraction. The only difference is now that we're seeing that on one side of the fraction we have an expression in place of one of the denominators. When we do this, we're still going to do the same method that we did before, but what you need to remember is that everything down here in this bottom part of the fraction is the denominator. So it's not just 5 or just b. Everything down there is part of the denominator. So let's go through and get this math done. So now I got 7 and 5. Those are going to be multiplied together when I cross multiply. And over here I know 10 is going to be multiplied by all of this b and this 5. So let's go through, let's rewrite what we got. On one side I got 7 times 5. On the other side I have 10, and that is times b plus 5. So let's take a look at the math that we got going on here. Now you may notice this happens to have a set of parentheses on it because I said I'm multiplying 10 by that whole other denominator. So now that we know that, that means we got to go through and simplify. So right here I got 7 and 5. 7 times 5 gives me 35. On the other side now, this 10, since it's outside of a set of parentheses like this and being multiplied, I need to now distribute this 10 inside of this set of parentheses. So I have 10 times b, which is 10b. And then I have 10 times 5, which is going to be 50. All right, so now we got our equation all written out here. So 35 equals 10b plus 50. I need to get b here by itself. So we need to get whatever is here inside of this by itself. So first let's deal with this 50. I need to move 50 to the other side by doing the inverse of what's happening. So the inverse of addition is us subtracting. So let's subtract both sides by 50. So over here 50s are going to cancel each other out. On this side I got to go through, and this is going to give me a negative number. So that negative number is going to end up being, I believe this is negative 15. And you could always go through and double check this in your calculator, okay? Now, I got negative 15 here. It is equal to 10b. Now I want to go through and double check what I have to do here. I got 10b on one side, negative 15 on the other side. That means that I'm going to have to divide now. So 10 and b are being multiplied, so the opposite is dividing. And I got to do the same thing over here, divide. So over here, this 10 is going to cancel out. On the other side now, we got 15 divided by 10. So negative 15 divided by 10 gives me, it's still going to give me a negative number, but it's going to be a decimal this time. So this actually gives me negative 1.5. And that is going to end up being our answer that is equal to B. So we found out what B is, but is our math correct? In order for us to check out our math over here, we're going to have to go through and we are going to have to plug in this B and see if these fractions are equal all the way at the end. So let's give us a little bit of space over here. We're going to just, section this off. Oop. And let's put our check right here. So as we check it, we know that we have 7 on top. And this time we have to put that negative 1.5 in for B. So let's go through, let's replace that. So 7 over negative 1.5 plus 5. That is equal to 10 over 5. Alright, so let's check to see if this all works here. So down here we're going to have to simplify. Negative 1.5 plus 5 is going to give us, that is 3.5 in the denominator. So what I'm going to do, let's just take this and move this down a bit. So we have negative 3.5 in the bottom of our fraction over 7. Let's make that a little neater. So we got positive 3.5 under 7. On the other side, we have 10 over 5. So let's check to see if these both are equal to each other when I go through and turn them both into decimals. Or just, actually do the division in this case. So I got 10 divided by 5, we know is going to give us 2. If I take 7 and divide it by 5, 7 divided by 5 should give us this. Let's double check. So 7 divided by 3.5 also gives me 2. So since both of these are equal at the end of it, that means that our solution here does work. So they're good. Alright, so that right now, we have number 6 all done, and we checked that out. So let's take a look at what we got for number 8. Number 8's going to be similar to what we did with number 5. So let's take a look. So for this, we see that we have another expression down here, and it is equal to an expression over here. I'm going to show you another method that you could use along with cross multiplying to make this a little bit easier for you to solve. Because some of you guys might prefer to solve an equation that is, like an equation. So we'll take a look at this. We have 4 over m minus 8 equals 8 over 2. Now, both of these fractions are equal to each other when we reduce it down, when we divide everything down. So let's take a look at our numerators. I know that if I reduce this down here, it is going to be equal to whatever is over here. So let's take a look at our fraction here. Let's see if we can reduce what we have. So I know I can divide 8 and 2 both by 2. So let's go through, let's reduce that. If I would divide 8 by 2, that's going to give me a 4. And if I divide 2 by 2, that gives me a 1. Now, what this really means is that over here, I have 4 over m minus 8, and it is equal to 4 over 1. Since both of these two up top are equal to each other, we can already assume that these here on the bottom are both also equal to each other. What we can do here, we could actually just go through and set what we have here equal to this, so we can go through and solve. Now again, like I said, this is just another way that we can go through and look at it, so don't freak out. So let's take a look at this new method, and we're going to compare it to the other method with cross multiplying and dividing. So I already know that this is equal to this. I now want to see, since this is equal to this, what m is. So if I'd set up that equation, I have m minus 8 is equal to 1. If m minus 8 is equal to 1, I need to get m by itself, so I need to do the inverse of subtraction. So the inverse of subtraction right here will be addition, which requires me to add 8 to both sides. So negative 8 plus 8, those cancel each other out. Over here I got 1 plus 8, that'll give me a 9. So that means that m equals 9. Now if I double check my math and plug everything back in here, so let's go through, we're going to go through and check. If I check my math and plug that 9 that I found in, then I should end up with two fractions that are equal to each other. So let's go through and do that. I have 4 over 9 minus 8, and that is equal to 8 over 2. Now, I know that 9 minus 8 is 1, so I have 4 over 1, and it is equal to 8 over 2. Now, if I wanted to go through and do that little bit of division, we want to make sure that that math works for all of us. So let's go through, let's do that division, and let's check to see if that math does work. So, actually, let's go point down, yeah. 4 divided by 1 is 4, and 8 divided by 2 is also 4. So that means that this works. We got 9 as what our m was, and it does work. Now this is one method of solving it. Alternatively, we can still go through and cross multiply and solve. So let's go through, let's check to see if that other method will also work for this. So if I go through and do this, let me just copy that over. Alright, cool. So we have our fraction all set up, and we're going to cross multiply this time, and then we're going to solve. So the numerator here times the denominator there, and in that same direction in the other side. So when I go through and multiply this out, I have 8 times m minus 8. That equals 4 times 2. Now over here, let's simplify. We got 4 times 2, that's 8. Over here we got 8 times m minus 8, so that means I got to multiply 8 times both of my two things, because this is the distributive property. So m times 8, that is 8m. 8 times negative 8 gives me negative 64. So I need to go through, I need to move the 64 to the other side, so let's go through and do that. The opposite of us subtracting will be us adding 64. So if I add 64 to the other side, that ends up giving me a 72. And I got 8m on my other side here. So I got 8m equals 72. Now, if I go through and deal the math, I know I got to divide both sides here by 8. And if I divide both sides by 8, this side gives me just m. 72 divided by 8 gives me a 9. So, just like how we got 9 over here, but with a lot more multiplication and steps involved. So, at the end of it, I still end up getting 9, no matter which method I go through and do. Now keep in mind this method here doesn't work as easily in some cases. In some cases, it involves, you looking at decimals, and it's, just a little bit, extra. So if you can go through and solve it with this way, more power to you. If you can solve it with this way, more power to you. So that is your prerogative on that. Now, before we leave off,